A very warm welcome to today's lesson where we carry on with set theory. Now this is part 3 of a series, so I'll put a link to the first 2 parts in the description below. The focus for this lesson is on cardinality or size and something called set builder notation, where we use a symbol. It's a pipe symbol or a colon. It means such that, and I'll come across that in a second and show you what it means. Now the cardinality or size. Let's say I have set A, and let's say that set A is equal to 1, 2, 3, and 6. And let's say we have a set B, and in set B we have A, B, and C. So what we can say is the cardinality of A, or the size of A, is 4. 1, 2, 3, and 4. So there are 4 elements in A. The other way we can say it is n with brackets A like that. So that is 4. And the way you'll probably come across it is this way here. For set B, obviously the cardinality of B, or the size of B, is equal to 3. And the same thing, we can say n of B like this, and that is equal to 3. So fairly straightforward. The next thing I want to look at is something called set builder notation. So let's say I have a set C. And inside set C, I have 1, 2, 3, 4, dot, dot, dot. Now those 3 dots means it continues all the way to infinity. It just keeps going 1, 2, 3, 4, 5, etc. Now the other way I can describe that set is using set builder notation. So C is equal to, still have my curly braces, and for all the elements, let's say we have the elements that are x. So x is just representing 1, 2, 3, 4, 5, etc. Now if I just write C equals the curly brace and x, I don't know what x is yet. So what I say is that x belongs to, now these are counting numbers. They're called the natural numbers. And the way we represent the natural numbers is with the symbol, it's an n like this, with another line down. So I'll write it down here. So we've got the capital N with another line down like that. And these are the natural numbers, just the counting numbers. So x belongs to the natural numbers. So that describes the same thing. So this second option here just means 1, 2, 3, 4, 5, etc. Now what if I had set D? And again, set D is 1, 2, 3, 4, 5, 6, and 7. So again, these are counting numbers. These are the natural numbers, but I'm limited to what they are, just the values 1 to 7. So the way I do it this time with set builder notation is I say D is equal to x belongs to the natural numbers. So give me the natural numbers, but this time I say such that we've got 1 and 7. So x lies between 1 and 7 and includes 1 and 7. So I can say using that notation. Let's have another example. Let's say I start with set E. Let's use set builder notation. So x belongs to the natural numbers such that we have 3 is less than x is less than or equal to 5. So what would that be? What would be in that set? Well, the set E would be the following. Well, we've got the natural or counting numbers 1, 2, 3, 4, 5, but x is strictly greater than 3 and less than or equal to 5. So in other words, we've got the elements 4 and 5 in that set. So that takes care of the natural numbers and a bit of set notation, but there are some other symbols you might come across. The other one is a capital Z with a line like this, and these are integer values. Okay, so these are integers. Now these aren't integers here that we've dealt with, but they don't include the negatives. So the integers, this Z here, integers, includes the negative whole numbers. So -5, -4, -3, etc. The other thing you might see is the Z with a plus. So that means just give me the positive integers. In the same way you might say it with a minus sign, which means just give me the negative integers. The other symbol you might come across is a capital R with a line. These are the real numbers. So it includes decimals 1.5, 1.23, etc. Now there are some other symbols, but those are the main ones that you should come across. The natural numbers and the integer values definitely. Usually sometimes the real numbers, but there are others like complex numbers as well, but I won't go into those. Let's have a look at a quick example here. So what we have is that the size of the universal set is 20. The size of set A is 10, the size of B is 13, and the size of the complement of A union B is 5. In other words, when we look at this A and B, everything in here, if we take the complement of that, everything outside of that, well, there are 5 elements outside of that. So in this section here, this universal set here, outside of A and B, we've got 5 elements. We've got to work at the size of A intersect B. And A intersect B is this middle section here. We don't know that size yet. Let's say it's X. So we can say something like, let X be equal to the size of A intersect B. Now we know the size of A is 10. Well, if the size of A is 10, the whole thing is 10, then just this area here would be 10 minus X. So this is 10 minus X. And similarly for B, it's 13. So this would be, this section here would be 13 minus X. So what we can do is we can set up a little bit of an equation here. What we can say is that 10 minus X, so this area here, plus the middle section, X, plus 13 minus X, plus 5, which is everything outside of A and B, well, that whole thing is equal to 20. We can cancel things a little bit here. We've got this X will cancel with this one. So what we've got so far is that 10 plus 13 plus 5. So we've got 28 minus X is equal to 20. And a little bit of a rearranging of this, we would have that X is equal to 28 minus 20. So X is equal to 8. So the size of A intersect B is equal to 8. If you found this video useful, then remember to give me a quick thumbs up. And if you would like to be notified when I release new videos, then hit that subscribe button and remember to click on the little notification bell.